Thank you very much, Pippa, for this nice introduction, and thank you for having me and giving me the opportunity to share my experiences I had with NOMAD Oasis in our perovskite solar cell lab at the University of Marburg. So before I really kick off, I would like to introduce myself a little bit. So I'm Aaron, I'm a master's student at the group of Professor Goldschmidt in Marburg, and we're doing some research on perovskite solar cells, especially on carbon rear side solar cells. Let me just get a laser pointer here. Carbon rear side electrode solar cells and all perovskite tandem solar cells. The group picture is a little bit outdated. We're now around 15 people, so that you just have a feeling of how many people are involved. We're quite a new working group in this field, so we're still in the progress of setting up the lab. You can see here some empty space where my colleagues are standing, and just last week our last big instrument was delivered. So we're really kicking off science, and this is an ideal position to implement like a research data management system directly from the beginning. And it should be much easier than being in a well-established environment and then convincing everybody to change the way how to use data or share the data. Okay, so the agenda for today is I would like to first show you how I got to NOMAD and what are the purposes and functionalities of our NOMAD Oasis deployment in Marburg. And the second part, this will be like a live demonstration, so we can really show you how actually our workflows look like in the NOMAD Oasis user interface. And in the end, I will tell you a little bit about some challenges, what is the status quo, and what is the outlook, so what may be there in the future. And then I'm happy to take some answers and have a nice discussion. Okay, my way with NOMAD started in autumn 2023. I was hired as a scientific assistant in this working group, and my task was, please implement a research data management system so that we can have a nice electronic lab notebook and get the most out of our data. And the idea was to have something like a database, like the perovskite database project Pippa mentioned just shortly. So people extracted all data from lots of perovskite papers and had a nice overview about all the different solar cells. And we wanted to have something for our cells locally, something like the perovskite database. Next idea was to have like standardized workflows so we can save some time in the analysis process. And we don't want to lose any data. And even better, want to have like high quality data, which just means data in a way which is structured that we can apply machine learning later on to the data. And yeah, this is also very useful. And also another idea was, like in the perovskite research, often very small things play a big role. And if you track everything, for example, if you track what is the temperature during processing, what is the oxygen level in my glove box all the time, which chemical, so which lot of which chemical is really built in this solar cell, then you maybe find some hidden correlations if you can track all this data and connect it to your results. This is also the idea why to go with like an ELN or a database for your data. Yeah, we wanted to track like all the chemicals and all the samples, as Pippa has shown, to get like a timeline of what processes were applied. The first thing was we thought, okay, let's go for ELAB FTW because it had a nice graphic user interface. Many people were using it. But then we, luckily, I would say, found out about NOMAD. We heard about people here at HU and HZB working with NOMAD. And also the perovskite database project was like migrating to NOMAD. I think many people involved in the database project are now involved in NOMAD. And this is why we then said, okay, don't do ELAB FTW, just directly go to NOMAD. And the reasons for the decisions are, for example, that the data in NOMAD and NOMAD Oasis is really more fair than, for example, in ELAB FTW, because we have like this lots of metadata behind our data. So it's not just numbers, but there are numbers with description. What is this? Which unit? And this is really good. Then we have two things in NOMAD. We have this database approach, but we also have the ELN capability. And I would say in ELAB FTW would only have the ELN capability, but not this big database approach. And so these are the two things which are important. And as already shown, it is highly customizable via this plugin mechanism. So I can write some Python code and change the design as I would like to have it. And also one big point, of course, it was already used in the perovskite community. So there were people here at HZB, especially Micha Götte, who were implementing like the space sections. So lots of work was already done, and it was a little bit easier to kick off with all the standard schemas Mika already has written. And then people at, I think at Erlangen are using it higher on KIT. And so it's good to do something together, yeah. And finally, also the option to publish to central NOMAD in the end is good, because then you have this open data thing in mind, and we want to share our data so we get the most together as a scientific community out of our experiments. Yeah, these are the reasons why we then said, okay, let's go for a NOMAD Oasis, and now we have a NOMAD Oasis here at Marburg. So what are the purposes or functionalities of our deployment? I put implemented into brackets because on some things I'm still working, and I don't want to say that everything works well, but this is the basic idea. So we have something called sample tracking, where I have a digital twin for each real sample, and in this sample there is information about which substrate was used, which processes were applied, which layers are on the sample, which characterization processes were performed, everything connected to this one sample. Then we have the ELN capability. So we're planning our batches in a standardized schema, not writing just some notes, not doing some Word files, but it's really a step-by-step schema, so it's identical for every scientist. And also the processes are in NOMAD, and after applying them in the lab, we apply them basically digitally in NOMAD also to the sample. You will see later what I mean with this. Then parsing measurement data, so we just zip our EQE and JV files, upload them to NOMAD, and then they're directly parsed and matched into nice schemas, and we can get the data with like an API call later on. Then we want to track our chemicals, ideally with things like QR codes, so you're basically in the lab and just taking a picture of the QR code and it automatically gets into NOMAD. This is not working yet, but I think we're on it. But the idea is that we know which chemical is in which solar cell, and not just chemical isopropanol, but which lot, so delivered on this day, so we can see maybe also like if we have a contamination in a chemical, and this affected our efficiencies or the VOC or whatever. And of course, if we have like an ELN, then we can also track and manage and monitor our instruments. If there is something like maintenance stuff, this would be also nice. And behind all of this is like the FAIR data and the iReady data thoughts. And the apps Peppo already has shown, like we have searchable database for our own solar cells, where we can filter nicely and get a nice graphic user experience for like exploring your data really. So the apps are really also something I want to work on and hope to get some input in these 2 days. Okay, in this slide, the last slide before the live demonstration, I just want to show you where in the research cycle the electronic lab notebook plays an important role. So normally you just read some papers, you have ideas, you have knowledge, and then you want to do an experiment. And you plan your experiment with a batch plan, then you go in the lab and fabricate your solar cells, you go in the next lab and characterize your solar cells, and then you maybe go back to your office, run some Python scripts or some other code to analyze your experiments and gain new knowledge. Maybe you publish it with a paper, or you just gain some knowledge for yourself to do new experiments. So this is the typical research cycle. And now NOMAD Oasis plays a key role in all of these parts to make it a little bit better, I would say. For example, the batch planning. If you do it in a standardized way, it's much easier to cope with the data later on. Also during fabrication, for example, if you, instead of spin coating 120 milliliters, just spin coated 100 milliliters, ideally you directly change it in your ELN so the data is stored correctly, and you don't have to assume, oh yeah, I was a little bit below the spin coating there. Then the parsing of measurement data is really important, makes things much easier. You just upload your files and basically get an automated analysis. And this automatic analysis you can do, for example, with North. Pepper said, I haven't used North yet. What I always do is I use the application programming interface of NOMAD, which means I make some API calls to our server, get the data back, run a standardized script, and then get all the plots locally on my computer. But it should be also possible like in the North tools. Okay, so you see that in all of these steps of the research cycle, an ELN hopefully make things easier, and you get more out of your data. Of course, sometimes things might sound a little bit more complicated, or there are always some tricky things you have to cope with. Okay, then I will go to the browser now to show you really some hands-on stuff. So go here. So this is the overview, the graphic user interface of Nomad. I'm now seeing a list of all my uploads here. And what I want to show you first is that you have to do a little bit of pre-work, or I did some pre-work. I created uploads like standard processes and standard substrates that later on people just can load those standard processes into their batch plans and don't have to write all the processes by themselves. So for example, here in standard processes, I have a list of a few processes. So this is just a test version, not the original version running on our server. And for example, we have here a spin coating process for triple cation perovskite. And if I go into this entry, you can see that, maybe I can zoom a little bit out. Minus, yeah. You can see that here everything important is saved. At the beginning, some general information, so what is the name of the process. The time, of course, will change for everybody. Where does it happen, a glove box or a fume hood, dynamic or static spin coating. But more important down here, this is basically what Micha Goethe has implemented, like a standardized schema for lots of processing methods. And you have information about which layer is deposited. So it's a perovskite layer with this material. We have information about which solution is spin coated, 130 microliters. Information about, okay, what is in this solution. Like we have really a list of all the solutes and all the solvents in here. We know what spin coating steps are performed, like 2 spin coating steps, speed, acceleration, everything is given. Something about the quenching, about the annealing time. So in this schema, everything important about the process is stored. And I just load this later on into my batch plan, make my small adaptations if I do something different than people did before me, and then I can go ahead. And this is what I will do now. So I go back to uploads, create a new upload. Just say, okay, this is a demo batch now. And then I create a schema, and I call this schema create batch plan. Okay. And you always have to give a file name for schema also, so I'm not very creative, just saying batch plan. But this is really not important how you name your file in here. Okay, and then I tried to get the most out of the current user interface of Nomad, and there is a new user interface in work, and it will get better hopefully. And I tried to make it as user-friendly as possible. So I have this like enumeration set up with checkboxes so that you can go step by step, that I don't have to explain everybody what to do, but hopefully people understand from the design what they have to do. So the first thing is they have to enter general information about the batch into the ELN fields below the description field. So we have here a description field, and down here some informations are like what is the start date. If my batch takes 2 days, then I can give an end date. I can enter me as a responsible person. I can choose from the few batch descriptions and enter a batch number, maybe like 4. And then I would click Save. And automatically a batch ID is generated and the first checkbox is checked. The next step would be to enter the used substrate. So I would go down again here, add my substrate in here, and now the good thing is that I have the standard substrates already prepared. So I can just choose from the standard substrates I have in my list here. For example, I take this FTO substrate, load the data from the standard substrate into the section, and have information about what is the substrate thickness, what is the conducting layer, what is the area of my substrate, everything in there. The same holds true for number 3, enter use processes. So I would go here, add my process. Typically we start with like cleaning processes, so I can click here, cleaning electronic lab notebook, and again choose from my standard processes. So here are quite a few processes, so I will filter them that I really have the standard processes in there only. So only the things in my standard process upload. And then I can, for example, take the ultrasonic cleaning here, load my process. And at this point now, I could still change stuff in this workflow. So if I say, okay, instead of only using like 3 steps cleaning, I want to have an additional step with maybe water, then I can just enter it here and have it in my own process, personalized. Okay, just let us add another process, maybe some spin coating. So I choose a spin coating, ELN. And again, filter only for standard processes. Let's do this triple cation spin coating in there. And this is identical to what I have shown you before, like the same schema. Everything is in there. Okay. And of course, for a full solar cell, you would need to enter like 7 or 8 processes, or I don't know, maybe even more. The next important step of an experiment is always like a variation. Typically, you have one parameter variation. So I click this button and move all processes now to a section called parameter variation. There are 2 ways I can vary parameters. Either it's a single parameter, or if it's a more complex variation and I have to change more than one thing, then I have to go a little bit a different way. But it's also possible in this setup here. Now I have to check. It is still loading and transferring the processes. Yeah. So now they're in this subsection, and I can say, okay, ultrasonic cleaning, I don't want to vary this process, but I want to vary my spin coating process. If I only want to vary a single parameter, I click here. And of course, people have to be told this, because no one would directly came up with the idea, okay, I have to click here now to vary my parameter. This is the little bit unintuitive part, but it should be possible to explain people. Okay, I can look for what I want to vary, maybe annealing time is something. I can give the unit, so in minutes, I would like to have 3 variations, 50 minutes, 60 minutes, and 70 minutes. And then I click vary process by the given parameter and immediately get a list with the varied processes. So here are 3 identical processes beside the annealing time, and not just in the title. Of course, also in the schema behind this, here in annealing, the annealing time was changed. Okay, so it's really changed deep in the data schema. And in the next step, I would now go to create groups. So maybe some of you are referring to this as sub-batches. We call them groups. And typically, you have one group for each variation and maybe some additional reference groups without an electrode, only the perovskite layer. So this is why I separated the variation from creating these groups. You would now enter here a number of groups and then create the groups. And I will skip to a different batch now to show you this. So here I have done this already. I entered 4 groups. And down here, you see the 4 groups. And in the groups, you would give information about what is the description of the group, what substrates are used. So typically, you engrave your substrate with numbers, and you can type in the numbers here. And down here in this list, you would choose which processes are applied. So you can either say your process is not present, or you select your process. In this case, I varied the blade coating. And I can say, OK, here for this group, please use the blade coating with blade speed 5 millimeters per second. And then I select the process, and it is changed in this table thing like. Has it already been changed? Did I click? I have to click present here. Yeah, and then it's changed here. So you can basically, for every group, check, I want to have this process in this group, I don't want to have this process in the group. And if you vary the process, you can choose the process from your variation list. So this is how you then create your groups manually. And then, in the end, you would create a PDF plan. This also doesn't work yet. The idea behind this PDF plan is that the supervisor has a little bit easier to see all your variations on one glance and doesn't have to scroll to all the NOMAD schemas and open to the right side, but really just sees, OK, this is the variation. Is it good? How many substrates are used? And then he or she can approve the batch, and you create your batch. After you created your batch, this maybe looks like this. So you have a list, a folder with all your processes in here. And you have a folder called batch with your samples in there and with your substrates. Okay? And later on, if you deposit an electrode, in this process, you will also create solar cells. At the beginning, I only have samples. A sample for me is substrate plus layers. A solar cell is substrate plus layers and electrode. And only when the electrode is deposited, then I create a solar cell. Okay. The idea behind having these process entries is that if you're in the lab, for example, and just did your spin coating of the mesoporous titanium dioxide, you would also do this process in NOMAD afterwards. So you still can change things, right? So if you say, okay, I spin coated too much, then you can change the value here, and then you click execute process and deposit layer. And this step, all the samples which are here under selected samples automatically filled in by the batch plan. Then the process is applied to all the samples. So we'll try this out now. I click execute this process, and then the samples here should jump into the sample section, not in the selector, so from selected to sample section. And if I'm now heading to this reference, to the sample, I should see my process in there. Okay, managing our way. So here, yeah, we have this mesoporous titanium dioxide layer now, and we have the process, which I just applied. And if you would apply all your processes in the correct order, then you would see here a list of all the processes applied. And later on also a list of all the measurements. Okay. I think Pepe has already shown like how easy it is to just drag a text file with a JV curve and you get the JV data out of it. I can also show you how this would look for us. So if I just take this JV file and drop it here, it is automatically parsed. It creates a JV measurement schema archive file. If I go in here, I see, okay, the solar cell was referenced. So the file found a suitable solar cell in NOMAD, and you have your data in there, you have your plots in there. Yes, this is how easy it is. With this, I would like to go back to the presentation and continue with my last slides. So the status quo is that we have a working NOMAD Oasis on our own server. It's still lots of work for me, I would say. I'm the main person using it. The other people are also using it, but often they have questions and come to me, and I have to help them. So this is a thing I have to improve, that they can work a little bit more independently on it. We have the schemas based on Michael's base sections for planning this batch, as I have shown, for the whole main processes in fabrication and characterization, and for this chemical and instrument management. Some passes for electric measurements, so JV, EQE, maximum power point tracking. What I hopefully can do this week here is writing some passes for optical measurements, photoluminescence and stuff, and maybe some of you already have written things and we can talk about this. And we have a nice workflow. So the idea is everybody plans his or her batches with NOMAD, uploads the JV and EQE files, zips them, uploads them to NOMAD. We run a standardized script which gets the data locally on our computer and makes us the nice box plots immediately. This works good until a specific point because every batch has individual challenges. For example, if you did 2 measurements for a cell, then you have to decide, okay, which is the better measurement. If you want to improve your plots a little bit, you have to adapt the code a little bit. But the basic structure is always the same, and you quite fast get these plots, and then you have to, of course, customize them. Okay, let's come to the end. So the conclusion after like 1.5 years working with NOMAD is the foundation is set, but I still have such a long to-do list, what should be possible. And at the moment, we're transitioning from a test server to a production server. Yes, this is the status quo. Here are some examples, what ideas we have. So it would be nice if for external partners, they send us cells for aging. And it would be nice if they just could go to our NOMAD Oasis and see in life how their cells are dying, or hopefully not dying, and how the cells are aging. Yes. Then this chemical tracking using QR codes is something I'm really looking forward, but I have to do some work on it. And we have this dream of a fully digitalized lab without any paper, just the tablets, that you are standing on your glove box and really after doing your process, just checking on the tablet, okay, execute this process also in NOMAD. This is the big dream, but there's still a way to go. The biggest challenge is, I would say, is making NOMAD attractive to colleagues, and this is why it's good that we're all here today and talk about stuff. Because the GUE is, of course, often a little bit of an obstacle at the beginning. I now, after 1.5 years, find my way through NOMAD very easily and can jump through all the schemas. But for people seeing the first time, it's always like, what's going on? Yeah. Then I'm interested to talk to you about how to train people in using NOMAD. What is the best way there? Is it like videos? Is it step-by-step guides? Is it the personal talk, which helps people the most? And in the long term, we need to keep the work for the Oasis administrators as small as possible. So make things as easy so people can use it straight away, and not we have to do all the work for the people implementing the badges in NOMAD, because this is not possible. With this, I would like to thank you all for being here, and I hope you have nice 2 days. Especially, I would like to thank Misha and Pepe, who were always there for me, especially at the beginning, and the people at the IT department of my university, which easily set up this server for me. Yes. Thanks to the whole NOMAD community, always when I have questions, people are very fast and helpful in answering. So, thank you very much, and maybe we have time for a few questions. Otherwise, we're here for 2 days, so there will be time.